Okay, that's my daughter on the other side of the camera. She's being subjected to chemistry. This is not her favorite subject. She wants to be an English major, so you can imagine her torture in having to do this. However, I'm sorry that we have to do this lesson this way. I'm in meetings all afternoon, so this was the solution to give you the content that we need to cover. We're going to continue on to Chapter 8. This is the last lesson in the Solutions chapter. On Monday, we talked about concentration in dilutions and worked a lot of problems with those. Today what we're going to do is do a quick little comparison of solutions, colloids, and suspensions. The main focus here is colloidal dispersions. And then after we do colloidal dispersions, I'm going to talk about colligative properties of solutions. And we're going to look at 3 of those colligative properties: osmotic pressure, freezing point depression, and boiling point elevation. And my hope is that you'll remember them this way: osmotic pressure increase, freezing point depression, boiling point elevation. And then at the very end of the lesson, I'm going to go through how to work some more example problems related to this chapter. So, as an overview of mixtures, different types of mixtures, we've been talking about solutions. Solutions have small particle sizes. The solutes are atoms, ions, or small molecules. As we remember from when I introduced this chapter, you can't filter out these particles with normal filtration. They're homogeneous solutions. They will not settle on standing, and they are transparent to light. Suspensions at the far end of this are very large particle sizes. You can filter these out. Think about large particle sizes like small coffee grounds that you can pass through a filter, so you can get those out. You know further that if you have those coffee grounds in a pot, they'll settle to the bottom, so you can get them to settle out. They are not homogeneous, and they can be, or generally are, translucent or opaque, dark solutions. Colloidal dispersions are in the middle, or colloids. These particle sizes are between 1 and 1,000 nanometers. They are still not filterable. They're borderline in terms of homogeneous solution or mixtures. They won't settle on standing. We'll talk about why that is. And they have a behavior of light called the Tyndall effect. And so the colloidal solution or dispersions would be protein mixtures, for example, very large macromolecules in solution. I picked this figure out of your textbook, and what's neat about this figure is it kind of gives a representation of those three types of mixtures. On the far left here, I don't know if you can see the dot on the camera, so you have at the bottom here are the suspension particles. They're the squares. The colloidal particles are triangles, green triangles, and then the yellow or gold circles represent solute particles. And so solutes being very small. And so if you had a beaker and you mixed up the stuff in the beaker, all 3 of those things in there, and then you let it set, the particles that would settle out would be the ones that would form suspensions. They would settle out. The colloidal and the solute particles would stay up in solution. They won't settle out, either one of them. If you put it into a filter, normal filter paper, you took this beaker and you started pouring it through, you'd notice that these particles would stay inside. The suspended particles would not pass through, but the colloidal particles and the solute particles would go through the filter paper into the bottom compartment. If you took all of this from this beaker and you put it into a dialysis bag, a bag that's semi-permeable, and you stuck that into another mixture, the solute particles would pass through, depending on the size of the bag, of the pore size in that dialysis bag, but they would pass through. The solution particles would, but the other particles would not. You wouldn't get the colloidal particles to go through, so it would be a way to separate them out. So I thought it was a neat little figure from your text to show that. So colloidal dispersions, or colloids, you named the same thing. Sometimes you'll hear people say colloidal suspensions, but that's not accurate. It's actually colloidal dispersions. Colloidal dispersions, you have dispersed particles of one substance, this is the dispersed phase, throughout another substance or solution called the continuous phase. So when we were talking about solutions, it was solute and solvent. When you have colloids, you have a dispersed phase and the continuous phase. Like I said, they're very large particles, 1 to 1,000 nanometers, and these very large particles have large surface areas to them. And because of those large surface areas, they can scatter light, causing the Tyndall effect. The Tyndall effect is what you can see right here. I don't know, I hope this is coming through in the video, but if you look here, you can see this light scattering pattern as the light goes through the second one. And in the solution, you don't see it. The light goes completely through the solution, but in the colloidal mixture, you see scattering of light. Then further with the colloidal, they form stable dispersions, which means that because of that large surface area, you can let it sit there and they won't settle back out. So dispersed phase throughout a continuous phase. And that's how we describe the different types of colloidal dispersions. Now these colloidal dispersions have various types to them. You can have a sol. A sol consists of solid particles dispersed through a liquid. You can have aerosols. Aerosols consist of liquid droplets or solid particles dispersed through a gas. An emulsion, which consists of liquid droplets dispersed through another liquid. Foams consist of gas dispersed through a solid or gas dispersed through a liquid. And then, one of my favorites is a foam. You'll see this when you come to it. And then gels consist of a liquid dispersed throughout a solid. And so what I'm going to have you do is on the next slide, I'm going to stop it. And when I stop it, I'd like you to take a minute of time looking back at this slide and try to answer the different types. So here we are. These are the different types of colloids. Looking at the phases, I'd like you to tell what each one of these is. Is it a foam? Is it a sol? And then once you've done that and answered it, restart the video, the second video, and see how you did. And you can see one of my favorites here, marshmallows.